Hi, today I'm going to show you how to solve systems of equations using the elimination method. Did you know the elimination method is actually the most used method, and it can really help with solving systems of equations. So let's go ahead and get right into the video. Okay, so to do elimination using systems of equations, we first have to understand the steps. So elimination, what we want to do first is make the equations in terms of x and y. Like put x and y on one side. Okay, second, what we want to do is find the LCM of x and y, least common multiple. Third, we multiply by the LCM, or the least common multiple. Fourth, solve for x or y, depending on which one you multiplied the LCM by. Fifth, what you want to do is use substitution. So you want to use substitution to solve for the x or y that you are missing. Okay, so these steps might not make sense now, and honestly they shouldn't unless you already know elimination. So we'll keep these steps to the side while we solve these systems of equations. Okay, let's solve the systems of equations right now. Okay, so we have this systems of equations to solve. 7x minus 3y equals negative 24, and 3x minus 7y equals negative 16. So what we want to do here is, since it's already set up in x and y form, we can skip that first step. So what we want to do is find the LCM, which is, for both, it's actually 21. So with the 21, we want to multiply one equation by 3 and the other by 7. So I say we do x since that's the first term. So let's multiply this by 3. And let's multiply the next one by 7 since. Okay. And with that we can get started. So 7x times 3 is 21x. And that's what we wanted actually. Minus 9y equals negative 72. And for the next equation we have 21x minus 49y equals negative 112. So what we want to do is we want to subtract both equations since we have 21x common here. And if we subtract, we get rid of the 21x. Negative 9 negative 9 plus 49 is just 40y. Negative 72 plus 112 is 40. And then we get y equals 1. So now we have y equals 1, so we want to find x. So let's plug it into any equation. I'm going to choose the second one, but you can plug it into the first one as well. So y equals 1, we have 3x minus 7 equals negative 16. So 3x equals negative 9, so x equals negative 3. So we have the solution negative 3, comma 1. So that's our answer for this problem. So this problem may seem daunting at first, but as you solve systems of equations using elimination, it gets much simpler. So now let's go on to the next problem. Okay, so let's look at some special cases using systems of equations. So if you ever get the case 0 equals 0, 1 equals 1, 2 equals 2, n minus 1 equals n minus 1, n equals n. If you ever get any of these cases, even the ellipses, what you get is you have an infinite systems of equations. And what I mean by that is you have the same line. So let's use the systems of equations. 4x minus 5y equals 1. And 4x minus 1 equals 5y. So we have the systems of equations. And what we can do is we bring 5y over to this side and we get 4x minus 5y equals 1. And if we bring the above equation down, we get 4x minus 5y equals 1, which is the same equation. So if you try subtracting them, you end up getting 0 equals 0. And this basically means they're the same line and you have a solution everywhere. Any point, that's the solution. So let's look at another special case. Okay, so let's look at the second case of systems of equations. The second special case you can get is something like 0 equals 1 or 0 equals 2. And we know that this is false because 0 does not equal 1 and 0 does not equal 2. So those are false. So if you get something like this, then the systems of equations has no solution. So let's do a similar example. 4x minus 5y equals 1. And we also have 4x minus 10 equals 5y. So if we bring the 5y here and the 10 there, we get 4x minus 5y equals 10. And using the first equation, we also have 4x minus 5y equals 1. And if we subtract the equations, we end up getting these cancel. All we're left is 0 equals 9, which is not true. So therefore, there's no solution to the systems of equations. And basically, when you see this, and you look at a graph, it will look something like this. One line will be here, and one line will be here. And they'll have the same slope. Otherwise, they'll intersect somewhere. So they'll have different intercepts, but same slope. Okay, so that's all for the special cases. And now, thank you for watching, and please be sure to subscribe as it helps me out a lot. And I'll see you in the next video. Bye.